All right, so looking at example 2, we have triangle FGH. Angle F has a measurement of 39 degrees. Angle H has a measurement of 32 degrees. And GH is 40. We want to find the length of FG. So right now, are we talking about a law of sines situation or a law of cosines?
Law of sines. Yeah.
This is definitely going to be a law of sines situation. All right, so, and the reason why you know this is because we have two angles, which makes life a little bit easier to use the law of sines. All right, so how are we going to set this one up?
Wait, we're trying to find FG.
We're trying to find FG.
Wait, Mr. Franklin.
Yep.
Sine 39 over 40.
Excuse me?
Couldn't
Couldn't I use what?
you use both?
Well, not exactly, because if you look at the law of sines, it requires two side lengths and one angle to use.
Okay, yeah,
So-
that makes sense.
Right, so we only have one side length. So we're not really going to be able to use the laws of cosines in this case, which you should be grateful because this is much easier. All right, so how are we going to set this problem up?
We could do, we should find the sine of 32 over
33.7.
FG.
Well, hold on a second. The sine of 32,
Over
the sine of 32 is going to relate to FG, right? Do we know what FG is right now?
No.
No.
No, so that's not going to be super helpful because we want to find the measurement of,
I know, but we could say that's equal to, then, F39 with over 40.
but that doesn't help us find, oh yeah, we're looking for FG. I thought we were looking for FH. My bad. Okay, that sounds great. Okay, so we have sine of 32 over, and you said X, okay. And that's going to equal
39 over 40.
Sine 39.
the sine of 32.
Oh, sine 30. No, I'm sorry.
I got 30.
All right, and so let's go ahead and use some cross multiplication to solve this one.
What's the sine of 32?
Forgive me,
0.5.
I do not have that memorized.
What? No way.
I know, it's shocking.
The-
Oh, geez, where did you pull my calculator? It was in that bag that was.
It's not yours, it's mine.
No, I didn't. No, I had another one in there. Do you know where it is?
What? I don't know, the bag's up
Mr.
here.
Frankie, I'll be right back.
Oh my god.
I can't believe it.
I'm gonna go pick him his bag.
Why don't they just go on one computer? Oh, never mind. It does not work.
All right, so what,
Thank you.
No problemo.
okay, so what is 40 times the sine of 32?
One sec. Let me pull my calc.
32. 21.19677.
I got 22.005.
Here, I'll do it again. Wait.
Okay, hold on, so we're having a
Sine 32.
disagreement here.
This time. Yeah, I still got 21.19.
I know this calculator. I don't know why, but every single time I do sine on flip versus my other calculator, it's wrong.
0.05.
You two got the same thing?
I got the same thing as Claudia.
Okay, so Claudia,
Maybe mine's messed up or something.
Miss Abby got the same thing you have.
No, I know it's wrong. There's something with my calculator where sine is different than other calculators. It like gets different. Okay, what are we signing?
Wait, 40 times.
Sine 32 times 40.
32
sine times 40. I got 20.56.
Yeah, maybe mine's messed up.
Claire, what did you get?
I got 21.196.
And it's 39?
32.
32. So I think we can safely say it is 22.
Yeah, it's my fault.
22.06, okay.
No, Mr. Fergie. Isn't it sine 32 times 40?
Yeah, that's what it is.
When you do... Oh, so I did this.
Yeah, you know what? How about you don't?
Don't shush
Do
it.
it. Wait, I didn't see it. 22 point what?
22.
But you have it on your calculator.
Not on my calculator.
All right, and so we
I
see,
got 20, wait, I got the same as Claire. What? 21.196?
Oh, okay. Wait, so I did
hold on a second, we're working on Claire's
sine.
calculator.
Wait, so I did 40 times sine 30. And no matter how I organize that,
Try
I
to
would
do sine of 32.
Okay.
sine 32
Claire, did you get the same as me?
times
Oh, could it be because she's in degrees and not radians?
Oh, well, no, she should be in degrees.
She should be in degrees?
So we should be in degrees. So there are two different ways of measuring. One is in degrees, where we're talking about degree measurements. But remember how that sine curve has a period of 2 pi? Or 6.28. So if we measure in radians, then we'll get a different number. So the big question is, are you measuring in
I'm
degrees?
radians.
I'm probably doing the wrong. Mine
I
has
think
like,
that calculator was in radians.
wait, Mr.
Okay,
Frankie.
and I'm in radians as well.
Yeah, Mr. Frankie.
Okay, so this is a good learning moment. Okay, so let's talk about this the difference between degrees and radian. So we have a circle, and
I just need to stretch out.
and this circle. How many degrees measurement do we have for the angle that starts here and goes all the way around?
360.
360.
There are 360 degrees in a circle. However, we can also measure this circle in that's relative to pi, right? So we know that the circumference of the circle is the diameter times pi, right?
Yeah.
Yep.
All right. Now, we're talking about a unit circle. So a unit circle has a radius of 1 unit. Therefore, what's the diameter of a unit circle?
2.
2. So what that means is the circumference of the whole circle is going to be equal to 2 times pi, which is approximately, 6.28, right?
That was very fun time.
So there's another way to measure how many degree or this angle measurement, and we would be using the fact that the unit circle has a circumference of 2 pi to go all the way around it. So this would be 1 pi. This would obviously be 2 pi.
I think
This-
we've talked about this before.
We did. This would be pi divided by 2. And this moment here would be 3 pi over 2. So if we're measuring the circumference of the circle, or the angle measurements of the circle, more the point, we could also measure in something called radians, which is talking about this relationship of the angle measurement in terms of how many pi's it has gone around. And we call that measuring in radians. Whereas if we're using angle like degrees, then we're measuring in degrees. Does that make sense?
Wait, how would you
Yeah.
change between
Okay.
one?
So,
Yeah, mine is. But
if I'm using this online calculator, you'll see this button right here. This is degrees, and this is radian. Now I'm in radians.
I don't even
See how it goes?
I've actually done that before.
Wow, that changes
I don't know how to
things.
select it.
All right, so I did this measurement in radians. I really need to do it in degrees. So I'm
In
gonna
degrees, I got 21.196.
there, and that's why we were getting that difference. I totally forgot about that.
Good thing you remembered.
Right, well, okay. Actually, I have to give credit to where credit is due. It was Miss Abby who remembered this one. All right, so the 40 times the sine of 32 in degrees is 21.19, well, let's just call that
196.
Just say 0.2.
Wait, Mr.
I
Framby,
like 0.2. Let's go with that.
Mr. Framby, how do we change sine into radians?
Well, so hold on, give me a second.
Does he have one of the blue ones?
Press the degree.
All right, so we found out that 40 times the sine of 32 in degrees was 21.2. All right, what are we going to do to both sides to get the x by itself?
Divide by sine 39.
Divide by...
Sine 39, I got 0.629.
I got 33.7 as the answer.
Oh,
Yeah, that's what I got. That's what I got.
Not a sine 39.
All right,
That's my answer too.
so we get x is equal to...
33.7.
33.7.
So my pen does not like writing so low. Oh my goodness, it's driving me crazy.
Why doesn't it like writing there?
I don't know. Okay.
Like, I don't think
Whew.
we meant to do
That took an awful lot of time, didn't it?
Yeah, now example 3.
No, well, let's try the other one in example 2.
Oh,
Well,
yeah.
Wait, there are two in example 2.
So this was one cube.
All right, so looking at angle Q, great. Are we talking the law of sines or the law of cosines?
Cosine.
Cosine, which is mean.
We have
It's not mean.
side length.
Because we have two side lengths, that is a giveaway that we're talking about the law of cosines. All right, so let's set this one up. All right, so I'm going to work right over here. So how do we go about finding angle Q?
We would have to do, we have to do sine like P or something. We have to use
Oh, wait, would we say... Wait.
what side length are we, we're supposed to find an angle?
Well,
Yeah.
okay. So let's write this in terms of this whole A, B, C stuff. So then we are better able to relate the equations that we have to this triangle. So let's call the angle Q our A. Let's call this B. And let's call this
I
C.
could use.
So which one of these?
Wait, why can we use sines? Law of sines
Oh.
in this one.
I don't know.
Yeah.
Why couldn't we?
You can if you want to.
Oh, so maybe we want to.
Yes, it's cosine.
So you would have sine q over 6 is equal to sine p, which is sine 51 over 8.
Okay. And do we know one of these angle measurements?
Yes, p.
P. Okay.
Yes.
All right. So in this case, it'd probably make a little more sense to just do the sine of 51 divided by 8, multiply by 6, right?
So 51 sine divided by 8. Then multiply it by 6.
Well, yeah, because
582.
the opposite of dividing sine q by 6 is
I got
multiplying.
0.582.
That... What? Sine Oh, I think I have... Wait, sine...
All right. Should we be in radians or degrees?
Degrees.
We should be in degrees. Okay.
I got 0.582. That isn't that right?
Yeah, that's what I got too.
So we want the sine of what number? 50.
51.
And then, well, then let's. I'm going to go ahead and divide it by 8. I think it was.
Yeah. And then multiply by 6.
All right. Now, do I have the answer I'm looking for?
No.
No. Oh, that's a bummer. What would I have to do now?
Sine, opposite of sine,
The
second sine.
the second sine. All right, so I do need to find the inverse.
Third power.
And that's 35.65.
Zero point 35 point. Whoa, I got.
Yeah, that's what I got, 35.65.
Okay, excellent. So that means we know the angle measurement. So
Can we
angle,
round to the nearest angle?
So,
So,
yeah.
sure. So that's 35.6, so that's 36, right?
Degrees. Yeah.
Yup.
Okay, now example 3.
Now example 3. All right, so if we spent so much time on the law of sines, guess what we're gonna get to do now?
cosine.
Law of sines.
The law
Are
of,
you okay?
law of cosines.
Or
So-
tangent.
So what do you notice is different between example 3 and example 2 that would indicate that we're talking about law of cosines instead of the law of sines?
We only.
Two side lines.
So we have 2 side lengths.
Oh, they're
Oh,
all
one-
adjacent, so then you
not two.
put it into the cosine.
So the angle is adjacent to both the side lengths we know.
Oh, yeah.
Which means we have no ratio that we can make, because for us to use the law of sines, we need to have a side length and the opposite angle in order to make that law of sines ratio. Whereas in this case, 35 relates to angle Z. We don't know that angle measurement.
Wait a second, it asked for xy, so don't we already know xy is 35?
There you go.
I was
Alright.
like, wait, that's so easy.
So then angle X relates to the 30 side that's 30 units long, but we don't know angle X. And angle Y is 110, and it relates to XZ. We don't have XZ. All right, so how do we set this problem up?
Okay, so what we would do, right, is y
A squared or x squared is equal to 35 squared plus 30 squared plus minus 235 times 30 times the cosine of y.
Wait, cosine. Would it be cosine? C?
Yeah, I agree.
Yeah.
It would be cosine 110 though.
110, right? And I should probably use a different letter than Y.
Yeah, sorry, it was the first number that came to mind.
So, but I can.
A.
So what I can do is I can use a lowercase y. Because remember,
Okay.
side lengths are lowercase, vertices are uppercase. So I can do this, and it should be fairly reasonable. All right, so now, this is just a matter of computation. You have a calculator.
Oh yeah, okay. So 35 squared plus
35 squared, not squared.
2125.
So what's 35 squared?
I don't know.
2125.
Both of them together are 2125.
I
Wait.
don't feel good about that.
35 squared is 12.5.
What? What do you mean you don't feel good about that?
Well, I mean,
Are you down?
remember, we're making this video for a member of our group that is not around.
And also for the 7th graders next year. They're
Right.
gonna have so much fun watching our videos.
They're
Yeah.
gonna love us.
Well, the chances are, if they don't love you now, they're not going to love you next year either.
Well, they love us now, but it doesn't matter.
All right, and so I don't want to skip any steps. So what is negative 2
I
times
took off the
35
square
times
from
30?
y.
What?
We took off the square from
All
y.
right, thank you very much for catching that.
Negative 2,100.
So 2 times 30 times 35. Claire's already way ahead of me. And we still have the cosine of 110. All right, so what am I going to do next?
1225.
Find the cosine of 110 and multiply it by 2100.
Okay, so and in the same step, let's go ahead and add the.
I'm betting you did it wrong, but I got negative 8.55.
That too, but
I have negative 3 point something.
Okay, well, let's do every step, okay? So by showing every step, we reduce the odds of doing something incorrectly.
I know.
Ooh, not one.
Okay.
Okay, wait. 2.
And so we need to find the cosine of 110. Could someone help me out? What is the cosine of 110?
Negative 0.34.
Okay, so let's multiply.
Oh! Okay, I did this wrong.
Oh, and I did that wrong too.
Negative 410.4.
I got 7, 18.
Times 21 year 0.
Okay, so if y squared is equal to 2125 minus 7.
Wait, I got
Oh, wait a second. So that's plus, isn't it? Because we have a negative times another negative, so it's a positive. Right?
Wait, I got 718 when I did it.
You got 718?
Yeah, well, negative 718.
So the difference here is, did you keep more decimal places?
Oh yeah, because I did cosine.
So I had to, I rounded. And that's why you have a slightly larger decimal. All right, okay. And so if I add these together,
That equals 2839.
okay. So
The net square root of 2839 is 53.28.
I got 2843.
You're wrong.
No, that's what I got when you keep all the decimal places.
So here's the thing.
Yeah, Claudia.
We're definitely dealing with your
That's correct.
Claudia, you didn't keep all the decimal places.
I did.
No, you didn't.
I got 53 too.
How did me and Claire both get the same answer?
I am grateful that Walter is not going to miss the bickering. However, here's the deal. We're dealing with numbers that go on forever and are not repeating, aren't they?
Mm-hmm.
Okay. So at some point, you are going to have to make a decision on rounding. The earlier you round, the lower your number is going to be. The later you round, the larger, more often than not, right? There's exceptions. So if we have answers that are really, really close, but off by just a little bit, that is probably a rounding issue. Does that make sense?
Yeah.
Okay.
Yeah, Avery.
I still got 53.3,
All right.
so.
All right, great. So right now, what I would like you to do is find the measure of angle T. This one is a little more by yourself, unless, of course, you're Avery, in which case you have the benefit of Tate.
Yeah. You love me.
All right, so 7 squared is equal to?
13 squared plus 11 squared.
Okay.
Minus 2 times 13 times 11.
Okay.
And then that is multiplied by the cosine of t.
Okay. So now, what was your next computational step?
So my next computational step was to figure out the exponents,
Okay.
which is, and 13 squared is 169. 11 squared is 121. And 7 squared is 49.
Okay. We can also go ahead and let's multiply 2 times,
And 2 times 13 is 26. And 26 times 11 is 286.
okay.
And then we would have to do negative 286 times the cosine of t. Wait, right?
Well, hold on a second. So the variable is now inside the cosine, so we have to do the inverse of the cosine. But we're not ready to do that because we need to get all of the numbers onto the left side. So let's go ahead. Let's combine 169 and 121.
290. Claudia, I'm explaining.
You were going really slow.
Okay.
Okay, and then even though we're multiplying negative 286 times the cosine of t, can we still do 9 minus 286 to get 4?
No, because that cosine of t is going to act as a variable, and you can't combine terms that are not similar.
Okay, then we would subtract 290 from both sides and
Okay.
get, I don't know, 49 minus 290.
That is negative 241.
241 is equal to negative 286 times the cosine of t.
Okay.
You can divide both sides up by negative 286.
I'm explaining!
Okay, I actually got a number. Wow.
Oh.
Yay.
All right. So when we divide this, what do we get?
0.08426.
Okay, Avery. I can't write that fast.
0.84.
That's why he's explaining slowly, because you can't write fast.
0.84. What comes after the?
26.
What comes after the 6?
5.
Well, then we can't end at 2.6 because we would have to round up to 2.7. Right?
That's 27.
Okay.
Yeah, Avery, round.
Kindness matters.
I think he's fuming.
I think he's doing a very good job of not retaliating.
Yeah.
It is a mark of a true gentleman.
Now he's gonna clear up on the black.
All right.
And then we would have to find the inverse of that,
Okay.
which is
32.57.
Yeah.
I got the same thing.
32.6.
All right.
Yay.
Oh, it's already 3 o'clock.
Now, there is no way that we can expect you to do this without any practice. So I'm going to assign some homework and we'll do a little more on law of sines and cosines tomorrow as well.
Do I need this anymore?
I don't know what this is. I can't see you.
The protractor thing.
Oh, speaking of the protractor, how tall, so what did you guys measure?
A wall.
I did the building and I'm like 80% sure I did it wrong.
Well, actually,
I did it.
I'm 100% sure I did it
I
correct.
did it, and I thought that it would be 17 feet tall,
That's
and then I
bad.
measured it, and it was like 12 feet tall. And so
Okay,
then I
so
did
I
like
got-
the opposite using the right height, and I got that the angle measure with my chronometer should have been like 65, but when I was doing it, no matter how I looked through the straw, it would always be 45. So then I just changed the thing and said I totally got 65.
so Avery and I, we did two
I
different.
got 6 meters for building.
How did you get it wrong if you did with Mr. Frankie?
Because we measured together, but I didn't do the math yet, and I think I got
Answer it.
6 meters tall, but I'm not sure if that's
Hi,
right.
Mother.
So actually, Avery, if you convert it to feet, our measurement at 10
Yeah, sure.
10 meters away was really close.
Okay.
Like super close.
Yeah, I got 6 meters and 5.95 meters.
So Avery, I think when you were 5 meters away, you know, as you had a steeper angle, the weight kept hitting your clothes.
That could have happened to me.
So I think that's why when you're super close,
5-minute timer.
it wasn't very accurate. But then when you got farther away, your 10 meter measurement was within like 6 inches of the actual height.
Oh, okay, cool.
That's pretty good.
So what's the homework?
That is a great question.
I think there should be any homework.
There is definitely homework.
Okay, yeah.
All right.
For me to have fun.
Okay. I know exactly what it should be.
I feel like homework should be optional.
Alrighty.
Yeah.
Yeah, but here's the funny thing. Even when we don't go over homework, the kids who do their homework almost always get much better grades than the kids who don't do their homework. It is.
You're practicing what you do at school. That
I
doesn't.
also feel like people who don't
Okay,
do their
wait,
homework
Mr. Frankie.
and people who do
I have
their
one more
homework,
question.
people who don't do their homework are also more likely to like not turn in other assignments.
Have fun.
But I'm talking about. I'm just talking about like if you look at their assessment scores,
Oh yeah.
there's a correlation between homework and assessment scores.
Yeah. Okay, wait, Mr. Frankie.
Okay, so
Did Hutchins leave?
I hope not.
What do you
He
want?
left.
5 exercises?
Yeah,
Wait, Mr. Frankie.
Basic, average, or advanced?
average.
Wait, he's a sophomore already.
14
Wow.
through 31, 39, 42, and 47.
Wait, what school does Hutchins go to?
Cherry Creek. On what page?
You saw it.
My class doesn't have any math.
What?
555.
My class doesn't have any math tonight, right?
If you did the quiz, oh no, nobody does because you all did the quiz.
Yeah.
All right, so I want to break this into 2 days.
Well, there's more.
There's more than.
What says if you finished example 1, 2,
That would be the next day. 14 through like 2, 3. 9 and 10.
How about 14 through 15 and that's it?
14 through 15?
How about
That's
14
it.
if you finished
through-
example
Well, you don't have to do all of the other problems tomorrow.
No, I'm saying how about we don't do any problems tomorrow and just do.
Oh yeah, I like that. How about we do 14 today and 15 tomorrow?
Okay.
Yeah, I agree.
So then we'll just
That
pick up
seems
the
fair.
ones that we didn't do here.
There's one thing I'll
Okay.
ever agree with Avery.
I thought you liked doing something.
Are you joking or not? Anything?
No, you
It's smart, okay? Not saying.
seem like you'd be the type of person.
Okay, so here we go. So I've knocked off about half of the problems by putting odd instead of doing all of them.
Does that mean it's tomorrow?
15.
So please have this in school for tomorrow.
Okay, I will
Yay.
try. Try.
Okay.
And then this is one more thing.
Yep.
All of my, you told me I didn't have to do the algebra homework, and all of my algebra homework comes up as missing, like including the mega high, because you told us we didn't have to do the mega high.
I will have to go through that. Don't fret about it, okay?
Alright, I have like a 46% in the homework for that.
Don't turn blue like Walter. Don't turn blue like Walter.
Okay, I will. If I don't remember to. Oh, geez. Hold on a second.